In this video, I'm going to show you how to quickly and efficiently model this adjustable wrench in Rhino CAD 3D software. To start, I want to go from my 4 default viewports to double-clicking on the word top, so that is my only visible view. My first command will be typing in the word picture to open up a file browser that will allow me to find a picture that I've saved to my computer. I click twice to place the picture, but now that it is placed, I want to scale it to an exact size. To do that, I type in scale into the command line, and I first have to place a base point, and then select a second reference point, and now I can scale the picture. I'm going to type in 8 inches because I know I want to make an 8-inch wrench. I now use the layers menu to switch from my black default layer to a red tracing layer where I can draw my lines. The first tool I'm using is the circle tool on the left side toolbar. Making sure my center snap is turned on, I'm going to draw a second circle with the same center point as my first circle. I can now turn off my picture default layer to show the circles that I've created. I am now going to use the control point curve tool and the tangent snap to create the top and bottom lines of the wrench. If the curve I am tracing is tight, I place my points close together. If the curve I am tracing is straight, I can space my points far out. I'm going to make sure I snap to my tangent once I get to my circle. I am now going to trace the bottom edge of the wrench. I want to note that this 3D model will be an approximate tracing of this image, not a dimensionally correct reverse engineered model. Because I snapped the end of my lines to the tangent of the circle, I can now use these lines to trim the command out the section of the circle that I don't want to be there. I'm going to select my lines as cutting objects and then select the line that I want to get rid of. I am now going to use the polyline tool to draw in the straight sections of the wrench. I am making sure that I snap the beginning of my polyline at the end of my curve and then the end of my polyline to the end of the bottom curve. Using these snaps will ensure at the end I will have one continuous curve to extrude into a 3D shape. I'm going to draw the adjustable side of the wrench as its own closed curve. I'm going to start with straight polyline segments and then use the control point curve to close the curve, making sure that I snap to the endpoints. As you can see, my line segments are all separate. In order to connect them, I'm going to hold down the Shift key, click all of the line segments around the edge, and then use the Join tool, the puzzle pieces in the toolbar, to join the 4 curves into one closed curve. Use this same Join tool for the adjustable side of the wrench. Now I'm going to create the rectangular hole at the head of the wrench. I could use the polyline tool to trace out the lines, but this is going to give me a rectangle without 90-degree corners. So instead, I will use the rectangle tool to first give me a rectangle with 90-degree corners, and then use the rotate tool to rotate it to align to the picture. Once it's rotated, I'm going to need to use the Scale 1D tool to scale it in the vertical direction, and then again to scale it in the horizontal direction. This gives me a rectangle with 90-degree corners. The last thing I'm going to trace is the indented groove in the handle of the wrench. For this, I am again using the Control Point Curve tool to give me this line. I am going to end this tracing with a vertical line segment from the end of the top line, making sure that it is vertically 90 degrees. This does not perfectly match with my bottom line, therefore I'm going to use the Trim tool to remove the excess line segment. Now that I have these corners, I want to round them to match the picture. To do that, I'm going to use a command called fillet. When using fillet, you have to input what radius you want the curve to be. Here I'm using a radius of 3 millimeters. Now my tracing is done. I'm now going to double click on the word top to switch to my perspective view. Now that I'm in perspective, I'm going to use the command extrude curve and select the main curves of my wrench. I'm going to extrude this a distance of 8 millimeters. In the command line, I want to make sure that the word solid equals yes. This will give me a closed shape. Once extruded, you'll notice that I don't see the solid shape. I need to drop down the viewport menu and switch to a shaded view to actually see my 3D volume. Now I would like to create the groove on the inside. In order to do that, I must first close this curve that I created by adding a line segment. I'm going to use the puzzle piece join tool to create one closed curve, and now extrude on the red layer to create a tool geometry. This geometry that I just extruded is going to be used as a tool to remove material from my wrench geometry. I am first moving the geometry down to intersect with my wrench, and then mirroring that geometry across the center axis of my wrench to reflect on the other side. I'm going to use a command called Boolean difference, which subtracts all of my red geometry from my gray geometry. Here you can see the likeness of the wrench is beginning to take shape. In order to round the edges of the handle of the wrench, I am first going to separate the geometry of the handle from the geometry of the head of the wrench. To do this, I'm going to create a line that separates these two geometries. I am shifting back to my 3D view in order to select this line and extrude curve. This gives me my border between the two sides. I'm going to use the command Boolean split to split the 3D geometry with the surface I just created. I can then delete the inputs, which leaves me with the two separate geometries. As I was modeling, I decided I would use the move tool and the near snap to close my wrench a little bit. I'm now going to work on rounding the edges of the handle of the wrench. To do this, I'm going to use a command called fillet edge. In the same way that we used fillet to round the corner of lines, once we're in 3D, we use fillet edge to round the corners of 3D geometries. We again have to specify in the command line the radius of the curve that we would like. Here I'm using a radius of 0.5 and a radius of 0.9 to create the curves that I want. While using fillet edge, it is very easy to miss a line, so be very careful to select all the necessary edges to round your geometry. Sometimes when using fillet edge, you may specify a radius that is too large for your geometry. You will know this has happened when your result is not a closed poly surface. In order to correct the error, I recommend clicking undo and then trying fillet edge again with a smaller radius. I'm going to finish this model off with a cylinder to stand in for the screw of the adjustable wrench. I first created a cylinder in the space, then I'm using the command rotate 3D to rotate that cylinder along the axis of the side of my wrench. This makes sure that the cylinder is properly aligned in that axis. I am then using the move tool and the gumball tools to roughly place the cylinder in the right spot. My last step of modeling is changing my viewport to a rendered view. This gives me a photorealistic view of materials and shading. I am turning off the visible lines, so all that I see is geometry and material. Right now my wrench has no material, but if I go to my layers menu, I can assign a material to that layer, which will then change the material of my wrench. In this screen recording, you are unable to see the pop-up menu that is the material editor. Here I am adjusting color, reflectivity, and texture of the wrench. Here I am going back to Display Properties to turn on the visible edges of this rendered view. This allows me to see the details of my wrench.